Alright, welcome back. So today we're going over one-step inequalities and how to solve them. This is handout 2 of the inequalities unit. So in this one, inequalities can be solved just like equations, but with a few exceptions. The first part of these steps here, the goal when solving inequalities is to isolate the variable, just like when solving equations. Step 1 and 2 are very similar, but step 3 is what we change when we're dealing with inequalities instead of equations. So step 1, we isolate the variable by using inverse operations or opposite operations. Step 2, the inequality must remain balanced just like equations, so we have to do it to both sides of the inequality instead of just to one side. And step 3, this is where it's different. If you multiply or divide by a negative number, the inequality sign is flipped. And so that's only for multiplication and division. And so go ahead and circle that one. That would help you remember that that step is different than with equations. So starting out, we have number 1 where we're going to check our work afterwards and graph it. So it says there, solve the inequality to check your answer, then graph the solution. To solve this one, we go ahead and draw our line to keep it organized. And then the opposite operation of adding 5 would be subtracting 5. To keep it balanced, step 2, I got to go ahead and do that to the other side. And now that I've done that, the 5's cancel on the left, and I'm left with n is less than or equal to 16 minus 5, which gives me 11. So to check my work, I go ahead and pick a number that's less than 11, and I'm going to go ahead and say n equals 10. I then plug it back into my original question here. Instead of saying n plus 5 is less than or equal to 16, I change that n to a 10. 10 plus 5 is 15, and 15 is less than 16, so we did correct work over here. I then go back to this number 11 here, and I'm going to graph that. So it's going to be a closed circle at 11, and then it's also going to be less than 11. So we already tested number 10, and 10 is to the left of 11, so that means my arrow has to go to the left. Number 2. I start out by keeping this one organized. I draw my line, and then I look for my variable and say, okay, what's the opposite operation here from minus? And that would be plus. So I add 8 to both sides to keep it balanced, step 2. And then cross off the 8's, because those cancel, and I'm left with C is greater than 14 plus 8, which is 22. I then choose a number that's larger than 22, greater than 22, and I'm going to go ahead and pick 23. And then I check my work. So I write out my problem. Instead of writing C, I'm going to write 23, and I subtract that out to get 15. And then we see, is 15 greater than 14? That is true, so then I can come back to 22 and I start graphing. And I write my numbers out. I find 22, and it's going to be an open circle, and it says these numbers are greater, so that means they have to go to the right, which is a number that we tested. 23 is greater, and 23 is right here, so our arrow must go right. Number 3. If I go through this problem, you'll notice that this has a number next to a letter. That means multiplication anytime you see a number next to a letter. So I go ahead and keep it organized. The opposite of multiplication would be division, so I'm going to divide by that number, which is 12. And then I'm going to go ahead and divide the other side by 12. And when I do that, the 12's cancel. They'll actually make 1. And then 1 times g is just g. And that's going to be g is less than 48 divided by 12, which is 4. I then choose a number that's less than 4. I'm going to go ahead and pick 3. G equals 3. I rewrite my problem, but instead of writing g here, I'm going to write a times 3. 12 times 3 is 36, and 36 is less than 48. So I know that numbers less than 4 do work. So I can go ahead and draw my graph now. It's an open circle at 4, and all the numbers that are less than that, so the arrow's to the left. Number 4. I start out by keeping it organized. I have p divided by 3 is greater than 9, so instead of being divided here, I'm going to multiply. And whatever I do to the left, I have to do to the right to keep it balanced. My 3's here, timesing and dividing by 3 cancel, and I'm left with p is greater than 27. So a number that's larger than 27, I'm going to go ahead and pick 28. If I was smart, I would pick 30 because 30 is divisible by 3, but I'm just going to pick the next one like I've always been doing. And I go ahead and take this, and instead of writing p divided by 3, I'm going to write 28 divided by 3. And if I do that, I get 9.3 repeating forever, but that is larger than 9, so it is true. I can then come back and do an open circle at 27. And as it says here, p is greater than 27, I would then draw my arrow to the right. Go ahead and think about some of the observations you can make about these 4 problems that we've gone over. What are some things that you've noticed about this? Any similarities between equations? Go ahead and respond to this prompt and then move on. Inequalities sometimes involve negative numbers. Remember that multiplying and dividing by negative numbers, if you multiply by them or divide by them, you must flip or switch the inequality sign. So if we take that information, I can go ahead and start on number 5, and at the very beginning I notice, hey, this variable is being multiplied by a negative. I know I have to follow this step for step 3 in our steps. Step 1, I'm going to go ahead and do the opposite operations. So you'll notice here that's only with multiplication and division, but to keep it organized, I draw my line. There's no addition or subtraction, so I go ahead and get rid of that multiplication by doing division, and it's a -4, so I have to divide by -4. As soon as I divide this side by -4, I have to cross off the inequality sign and write it the other way, or flip it to the other way down below. I then can divide the other side by -4, and my -4's cancel. So now I'm left with k is greater than or equal to, and then 22 divided by -4 would give me a -5.5. To check my work, a number that's larger than -5.5 would be -5. I then rewrite my problem. Instead of writing k, I will write -5. So then I can put in -4 times -5, which is 20, and 20 is less than or equal to 22. So we did correct work over here. I then set up my graph. I could have counted by 0.5s, but I think it's easier just to count by 1s, or in this case we're counting up from -7 to -3. At -5.5, which is between -6 and -5, I would do a closed circle, and it's going to the right because these numbers are larger or greater than. Number 6, I'm going to go ahead and start by keeping it organized. You'll notice that this s is being divided by -2. Now, anytime you divide by a negative, you must flip the inequality symbol or switch. So I go ahead and times both sides, that's the opposite operation, by -2. Because I'm timesing by -2 to this variable, I have to switch the inequality. I then times the other side by -2. Timesing and dividing by -2 cancels, and I'm left with s is less than 5 times -2, which is -10. A number that's smaller than -10, that would be -11. So I'm going to go ahead and test -11 here. Again, if I were smart, I'd probably try to test like -12, because that would let me know if I was doing it right, and it would be an integer rather than a rational number. But I go ahead and plug in -11, and when I do -11 divided by -2, I get 5.5. And 5.5 is greater than 5. So then I can go ahead and start graphing at -10. So I have my -10 there, and it's going to be an open circle because this does not have an equal sign underneath it, and it's going to go to the left because it says these numbers are less than or smaller than. Alright, last thing, we're going to go ahead and solve each inequality and graph their solution. So I'm going to go through the example and kind of help you out with this. I go ahead and start these examples just like before, and I separate out my terms here, or separate out the equation so I can keep it organized. And in this case it's being multiplied by -7, so I have to divide by -7. Step 3 states that I have to flip the sign because it's being divided by a negative, and then I can divide this other side. The -7's cancel on the left, so I'm left with x is less than or equal to -5 on the right. So I can rewrite that down below, and then from there it would be a closed circle at -5, wherever you put that, and it says these numbers are less than, so it must go to the left. Number 8. draw my line to keep it organized, and I would go through and add 16 to both sides. If you did that correctly, you would get x is less than 27. I then can graph it. It is an open circle at 27 and going to the left because it's less than. Please make sure you show your work on here and check your work as you go along. Number 9. My first step here, keeping it organized, I draw my line, and that says x plus 10, so I would subtract 10 to both sides, and when I do, I would get negative 2 is greater than or equal to x. So that is a closed circle at negative 2, and that closed circle is going to the left because it says negative 2 is bigger than these numbers. So then I can come down to this one. Looks like I already pushed the wrong button. It kept going. Great, fantastic. Congratulations. No, so from here, I would take this one, and it says there x divided by 8. That means I have to draw my line, keep it organized, and then times both sides by 8. That does not flip the inequality because I'm not timesing this x by a negative. So then I go ahead and keep that x is greater than negative 24, and that would be an open circle at negative 24, and x is larger or greater than, so it would go to the right. Okay, so our next one, I would go ahead and take this one, draw my line. This is 6x, which means 6 times x, so I need to do division. And I would divide both sides by 6, and I would get x is greater than or equal to negative 18. Notice my inequality did not flip because I'm not timesing or dividing x by a negative. Then I can go ahead and graph that. And I would have 18, negative 18 here. It's a closed circle at negative 18, and it says x is greater than, so then it would go to the right. Last but not least, we have negative 15 is less than or equal to x plus 7. So to get rid of this x plus 7, I draw my line. The plus 7, I would subtract 7 to both sides, and I would get negative 22 is less than or equal to x. That means it's going to be a closed circle at negative 22, and it says there x, negative 22 is smaller or less than x, so it has to go to the right. Hope that was helpful for you. If you have any questions, let me know. Please make sure you write down 2 sentences or more to describe what you went through today, and good luck.